Assalamualaikum and hi to everyone. My name is Yusuf Adli and we are from group Pil Lajakkuruih Set D. We are present to you about our product which is Pil Lajakkuruih Set D. Our group consists of me, Ammar, Wasfi, Ismail and Luqman. Lajakkuruih is a health supplement diet tablet that produced by Lajakkuruih company. It consists of 15 types of Lajakkuruih tablet with different health properties. Basically, common problems that manufacturer operation face is about the fluctuation in tablet weight and inconsistent tablet hardness. As we can see here, the characteristics is weight, relative density, and also the tensile strength based on the shift, evening, morning, and also night. In this assignment, we were assigned to choose which tablet name that we want to analyze and answer the question that be given to us. After a quite short discussion, we decide to analyze Pil Lajakkuruih Set D as our tablet. The tablet characteristic were given as I mentioned before. Without wasting time, let's move to the first question. In the first question, we are asked to describe and analyze this Pil Lajakkuruih Set D in the numerical, tabular, and graphical form. First of all, we need to sort the table characteristic from shift, evening, morning, and night. After that, the pivot table was being created. The pivot table is summarized by using numerical form. As you can see here, this is the summary based on weight, and this is the summary based on relative density, and also this is summary based on tensile strength in the numerical form. From this numerical form, we can see the important variable in statistics such as number of sample, sum of characteristic, average, standard deviation, and variance. Actually, all these values can be calculated manually, but since our data is too much, we need to use Microsoft Excel in order to make our task run smoothly. Besides, we also can summarize it by using tabular form. This form is more functioning when we are calculating the hypothesis test or other X. In this tabular form, the variable is actually the same in the numerical form, but for this form, we are not needed to provide the shift because the variable is from the overall calculation of the variable from each characteristic. As we can see what I shared to you right now, the variance based on weight is the same as in the total in the numerical form. Such example, the variance in the tabular form is 171.15 and the variance of weight in the numerical form is 171.15 also. This is also the same explanation with the relative density and also for the tensile strength. Last but not least, for question A, we need to provide the graphical form in order to explain about the weight and the hardness of the tablet as mentioned in the introduction, because it is the common problems that manufacturer have been faced with. Based on the graph of the summary of weight here, the highest of weight is on the night shift, while the lowest sum of weight is in the morning. For the variance, the night shift is the least among the three shifts. Therefore, we can conclude that the best shift of the tablet weight is in the night shift because it has the highest sum of weight and the smallest in terms of variance. In this situation, the variance is considered as the consistency of the weight. Next, we will discuss about the hardness of the tablet. Generally, the tensile strength is dependent on the relative density regardless of the production shift. So as we can see here, the as we can see, the figure in the relative density in the morning shift is the highest average compared to another shift. So we can conclude that the among of the three shifts, the hardest tablet that had been produced in December 2020 is on the morning shift. Next, I will let Muhammad Ismail to present about the next question.
Okay, Assalamualaikum. My name is Mohd Ismail. So I'm also from Pil Lajakkuruih Set D. I will continue Yusuf part. So for this question B, the Food and Drug Administration Authority requires that weight of standard tablets produced by manufacturer should be normally distributed with 350 mg with standard deviation of 14 milligrams. So comment whether there is significant evidence that Lajak Laku tablets produced in December do follow this distribution. So When doing this question, I'm dividing in several steps, which is the hypothesis statement, the test statistics, the decision rule or rejection rule, and then the conclusion. So first step, we have to see our data in Pil Lajakkuruih set D. So in this data, the minimum weight is 315.7 and the maximum weight is 380.68. So I'm dividing in several class limit from 310 until 319. And then bin is the upper limit. So when doing the bin, we must insert the data analysis and then we will get the frequency lah. Okay. Without calculating one by one, we can get from the Excel. So when getting this type of table, we can insert in our report project. Okay, so step one is the hypothesis statement, which is the H0 and then the H1. So the H0 is the weight of tended tablets follows the normal distribution of 350 milligrams with standard deviation of 14 milligrams. So H1 is the weight of standard tablets does not follow the normal distribution of 350 milligrams with standard deviation of 14 milligrams. So this is as the usual of hypothesis statement that we already studied. So step two is the test statistics. So the first one, I will do the frequency table. So this is the class limit from just now we get from the Excel. So bin is the upper limit and then the frequency, that's the same. Okay, so this is the frequency table. And then we will do the goodness of fit test. This is very important because when doing this, we will get the goodness of fit test value. Okay, so for example, this is the first row. Okay, this is the first row as well. So probability PI in terms of Z negative 2.86, where that I get this from 350, which is the mean, minus with the 310, and then dividing with the standard deviation, which is the 14, we will get 2.86. And then when getting this, we must refer on our statistical table in the Z distribution. So we will get the value of the PI. Okay. So the OI is same as the frequency, which is this one, 0 to 15, 27. So EI is N multiplying with the PI. So N from our Excel tablets, from our Excel Pil Lajakkuruih set D, the N is 200, which is the sample data. Okay, so 200 multiplying with the PI, which is 0.0021, we will get 0.42. Okay, so this is the same steps. We'll be doing all the columns. So, okay, what the meaning by OI this one? So the rules for OI and also EI, the value must be upper than 5. So for example, this one is 0. So we must multiply below it, which is we must adding. So we must adding by 2 and then adding by 15, because when adding by 2, it will not be greater than 5. So we must add another column. So it will be 0, adding by 2, adding by 15. So we will get 17 here. Okay. And then when adding the OI part, we must also adding the EI part, which is 0.42, adding with 2.82 and then 12.04. So we will get 15.20. Okay, so this part. So for example, this part 27. So we just write as usual. And then the last part is the formula of goodness of fit test, which is OI minus EI squared and then dividing by EI. So OI, for example, is 0 minus with 0.42. Okay, so squared this one, and then we must divide it by 15.28. So we will get 0.1936. So this is first example that I will be explaining lah. But the step is same for all this. Okay, and then when getting all the goodness of fit test, we will add all this and then we will get one value which is 2.9955 in our question lah, in my set D question. So when getting this is the goodness of fit test that we already get, and then following the step 4, this is same as the rejection rule or decision rule lah. So we must compare the goodness of fit test value with the x power 2 alpha and b. So this value we can get from the statistical table. So for example, the formula for v is k minus p minus 1. So k is this one, which is OI. So 1, 2, 3, 4, 5, 6. So k is 6. And then p is the, because of our question, produced by mean distribution and also the standard deviation. So we assuming the value of p is 0 and then minus with 1. So 6 minus 0 minus 1, we will get 5. So this is the value of v lah. So the value of alpha is static, which is 0.05. So when referring in our statistical table, x square alpha v, so x square, the alpha is 0.05, the v is 5, and then we will get one value which is 11.04705. So this value and this value 2.9955 we can compare. So when we doing the graph of the to know the where is the rejection part, so we will get that because of this one 2.9955 is lower or lesser than 11.0705, so we will fail to reject H0. Okay, so when we doing the graph, the value of this one, the value of this one 2.9955 will be outer from the rejection part. So because of that, we fail to reject H0 or we accept H0. So the conclusion we must refrain in our hypothesis statement, because of we fail to reject H0 means that we accept H0. So the weight of standard tablets follow the normal distribution of 350 milligram with standard deviation of 40. So this is the same. We can conclude that at alpha 0.05, which is the static alpha value of 5% level of significance, there is a significance evidence that the weight of standard tablets, Lajak laku tablets, produced in December 2020 follows the normal distribution with mean 350 milligram and the standard deviation of 40 milligram. So this is basically referring in our hypothesis statement. So this is the several steps in doing question B. Thank you.
Assalamualaikum and good day. I'm Luqman and now I will explain and answer the question C. Question C is comment on whether there is a significant difference between the tablet weight mg from different shift. Okay. Firstly, I have sort the weight by each shift, which is the morning, evening, and night. I use the ANOVA single factor features in the Excel to summarize the data. Okay, for morning, there is 62 of weight, for evening 64 and night 74. Okay, now the SS is stand for sum of square, DF stand for degree of freedom, and MS is stand for mean square. Okay, the first decision rule is reject H0 if the F calculation is greater than F critical. Okay, from this ANOVA table, since the F calculation is less than F critical, so there is not enough evidence to reject the H naught. Okay, the conclusion for the first decision rule is the mean tablet weight of different shifts are equal. Okay, we move to the second decision rule, which is the reject H naught if the p-value is less than alpha. Okay, since the p-value is greater than alpha, we use alpha 0.05, so there is not enough evidence to reject the H naught. The conclusion for the second decision is there is no significant difference between the tablet weight in mg for all shifts. Okay, I think that's all for the answer of the question C. Thank you.
Assalamu alaikum. My name is Wasfi Saber and I'm from Group D. So I'm going to explain about Part D. So in Part B, as we see, the question is it gives some information about the batch was produced a cluster tablet that shows the different relative density values with the 68, 74, and here's the question, like, based on the current data in December 2020, what's the production of the tensile strength for such tablets? So in here we have an ask for a comment on validity of model that you have used to carry out this prediction. So we, as in Excel, we use a method called regression analysis. So in here we let the linearity of regression and hypothesis to be HO and H0, HO and H1. So in HO the beta is equal to 0, in H1 the beta is not equal to 0. So if significant F is smaller than alpha, then we would reject HO. So as you see, we have the regression analysis, we have the regression status with the multiple R, and we have ANOVA, and we have the data for also the coefficient, the intercept and relative density. So here the Pearson's product, moment correlation coefficient, and multiple R as we got from the calculation, it's equal to 0.844, and while the significant F is 1.4 multiply e1 to the power minus 55, as we see that it's smaller than alpha, which is 0.045. So here we can reject the HO, and we can finish, or we can finalize that the data which is exist in December 2020 provides a very strong clue and evidence that 5% of significant level of linearity exists in the regression model.